Section 1.4, this is combinations of functions. I'm going to go through this kind of fast because it's not terribly difficult. Sum difference product quotient, that's what's listed here. They will write this as f plus g of x. All that means, when they write it like this, that just means you're taking f of x and you're adding g of x to it. So like part A right here, f of x is x squared, g of x is 2 minus x. So I am literally taking x squared plus, I'm taking this guy plus this guy, 2 minus x. And then I just combine like terms if I can, write them in descending order. So I'm going to write x squared first, and then I'm going to put the minus x next, and then I'm going to put plus 2. And that is what he looks like. So, yeah, when we rewrite him, when we combine like terms, we drop the parentheses. Okay? Same thing with f minus g. So that just means f of x minus g of x, like it's listed here. So I'm going to take f of x, which is x squared, and I'm going to subtract the g of x, which is 2 minus x.
Smaller? It's like,
can I do it?
Like smaller, so she can see the difference.
Like that?
Yeah.
Okay, now the difference between this one and the plus is what?
Plus x.
Yes, we have to distribute the negative. So x squared minus 2 plus x is what that will look like. And then I'm going to put it in descending order. So please do that.
I was like, can't you just do plus
X squared plus x minus 2 is how I'm going to write the final answer. Okay, good? All right, what is C asking you to do? Multiply them. So I'm going to take x squared, and I'm going to multiply 2 minus x. So I need to distribute the x squared through. So 2 times x squared is 2x squared. 2 times negative x is minus x to the third power. And then I'm going to put it in order.
So negative x.
So negative x cubed. And then what?
Minus 2x.
Plus 2x squared, because the 2x squared is positive. So there he is in
Are we
order.
doing the composed ones?
Yes, we are. That's down below. Okay. F over g means we're taking f, which is x squared, and dividing by 2 minus x. Okay. Now, when I do this, there's nothing that I can do to simplify him. X squared over 2 minus x. There's nothing I can do. But I have to also include what x can't be equal to, because now I have a domain error. So what can I have x not be equal to, because I don't want to divide by 0?
X can't be 2.
X can't be 2, right? So I have to include both of those things. So when you're doing a quotient and when you have a fraction, make sure you include what x can't be. Yeah?
Yeah.
Good? Okay. Now, suppose, let's say f of x, I'm going to do one more example, f of x and g of x. Let's say, for example, this guy is x squared plus 5x plus 6, and this guy is x plus 3. Okay? And I say find f of x over g of x. So that would be x squared plus 5x plus 6 over x plus 3. Can I simplify that?
No. You have to break apart the top.
You have to break apart the top. So the top breaks down. He's a simple trinomial. What can you multiply to get 6, but when you add them, give you 5?
How known is that?
Multiply to get 6, add to get 5.
No.
X
3 and 2.
plus 3, x plus 2. That's what he would look like. Get out of here. Go, now.
And you can cancel out the x plus 3.
You cancel out the x plus 3's, so
X plus 2.
x plus 2 is the answer. Yeah? So be careful, because sometimes you might, when you're dividing, depending upon what you're given to start with, sometimes you might be able to simplify. So look for those types of things. This one down here, x squared and 2 minus x, we cannot cross like the x is off or anything like that, because this 2 minus x is trapped. We couldn't just cancel this x with one of those, right? Okay, that's illegal because the 2 minus x is trapped. But sometimes you might be able to reduce. Okay? Good? Down here, definition of composite functions. Okay, so this is like the fog and the goth, right? F composed of g. This is like f parentheses g of x, okay? So when they write it like that, you put the inside of the outside. So g of x goes inside of the f function, okay?
I had this on the ACT.
Right.
Plug the other one into
So whichever one comes first, you
Me
plug the
too.
second one into the first one. So right here, if you want to
Yes.
write this as f parentheses g of x, you sure can. That's what fog means, okay? So what I'm doing is I'm taking the g of x and I'm plugging it into the f equation. So this is g. G is 4 minus x squared. And where do I plug it into the f?
Into where x is.
Into where the x is. So rather than him being x plus 2, Now I put the 4 minus x squared in that spot. Does that make sense?
Wait, how come that one on C has a negative 2?
What do you mean?
C has a negative 2 instead of x.
Just wait, we'll get to that.
Okay.
Okay, so now I want to do this. 4 minus x squared plus 2, anything I can do to simplify?
Yeah, no.
The 4 and the 2 can go together.
Yeah.
They're like terms. But let's put them in order. So negative x squared should come first. And then 4 plus 2, this would be plus 6. That's what he will look like if I put him in order. Yeah? Okay, now this one's a little bit more unpleasant, but that's okay. G composed of f of x, that's like G parentheses f of x. So now in this case, my f equation goes into my G equation. So now this guy is getting plugged into here. So 4 minus x squared, and instead the x is now x plus 2. Does that make sense? The x plus 2 is going inside. Now we have to FOIL, right? This is a little bit uglier. So I'm going to put x plus 2 and x plus 2 up here. Okay? Can you guys do that in your head? X plus 2 times x plus 2 and combine the middle terms?
X squared plus 4x plus 4.
X squared plus 4x plus 4. Because you'll have a 2x and another 2x right here, which will combine. So x squared plus 4x plus 4. All right? 4 minus. Now be careful when you're doing this because we still have that x squared plus 4x plus 4 in parentheses. And then we have to distribute the negative, right? That negative goes for everything. Okay?
X squared minus 4x.
So 4 minus x squared, yep, you're right, minus 4x minus 4. Okay? The 4's can cancel out. That's a lot of 4's. This 4 can cancel with the negative 4. So it's just negative x squared minus 4x. Okay? That is what you do when you're doing f composed of g of x or g composed of f of x. Okay? We're just plugging the one equation into the other one. But, Liddell says in part C, it's not an x, it's a negative 2. Okay? So what we're doing here is we're doing g composed of f of negative 2. So we work from the inside out. We're going to do f of negative 2 first. Now when I ask for f of negative 2, what does that mean?
Negative 2 and x.
You plug negative 2 in the x for f, right? So to find f of negative 2,
Negative 2 plus 2 is
I'm going to do negative 2 plus 2, because that's what the f equation says. So f of negative 2 is 0. Now I know that this guy right here is 0. So now I have to find g of 0. I'm plugging 0 into the g. Hold on. Okay, plugging 0 into the g, so 4 minus 0 squared is 4. There you go. That's my final answer. These ones don't have two answers. Like 0 is not my answer. 0 is just like the first half to get to the final answer, which is 4. Make sense? What?
You back up.
So,
Back up where? There?
why didn't we just do negative? Oh, because we plugged in negative 2 for f. And we
So
have
when you
0.
divide them,
Mhm.
do you have to put
Yes.
that x
Yes.
We put
Yes.
0 in.
But you don't have to change anything.
What?
You just put them one over the top.
No, unless
Okay.
they're like this. This is the example that I gave you. So f of x is that, g of x is that. I just made those up. And I said f divided by g, well, this top part can break down, and then it's just x plus 2. Okay, so if
So-
they will break down and you can cancel stuff out, by all means do. That one did not.
So g is 0 because f is 0. Like in the beginning.
What?
F is 0.
You're plugging 0 into g because f of negative 2 was 0. Yes. Okay? Good? All right, now, domain. We got 2 left. Domain, find the composition for the function given by this guy and by this guy. Okay? So f of x was this, g of x was this. Let's first, before we do anything else, let's find the domain of this guy and let's find the domain of this guy. Okay? So what's the domain of x squared minus 9? What am I allowed to plug in and not allowed to plug in?
Not in
not allowed to plug in
Oh, but you can
3.
put
Wait,
0.
no. You just don't want to square root. But it-
Okay,
negative
so the
square
two
root.
things that I'm looking for is a negative inside of a square root and dividing by 0, right?
Yeah.
So for this f of x, am I going to end up with either of those things happening? No, so this one is all reals, right? I can plug any number I want to in for x and that will work out. It's just a quadratic function, x squared minus 9, okay? But g, I have to worry about plugging numbers in for x here. So we have to figure out what numbers I can and cannot plug in for x. So I'm worried about getting a negative inside of a square root.
But that's
So
a negative.
anything
Okay.
that is greater than
So
10.
what we do first is we do 9 minus x squared, and if I set that
Okay.
equal to 0, we have to figure out what x can be, right?
It cannot be
Anything
Okay.
anything
because it's
greater
a
than 9.
negative.
So 9 equals x squared, and I take the square root. What's the square root of 9?
Can't be anything greater than 3.
Yeah.
Okay, hold on.
But
Plus and minus
I
3.
already squared.
Okay? So I'm going to put negative 3, positive 3 here. Okay? Then let's test the points. You guys remember doing this? Negative
Yeah.
4,
I think
0,
we
positive
already
4.
figured out the answer.
Okay, just wait. So negative 4, if you plug negative 4 in there, is that bad? If I plug negative 4 in.
Between the two.
It's between the two, right? You can plug 0 in, but you can't plug negative 4 in. Like negative 4 squared would be 16, and 9 minus 16, that's a negative number. Same thing with 9 minus 16, which is 4 squared. Positive 4, if I plug that in, that doesn't work. And this doesn't work. So the answers that I get, I can only plug in numbers between negative 3 and 3. Yeah? So the domain for this guy is negative 3, less than or equal to x, which is less than or equal to 3. This says I can only plug negative 3 to 3 in for that function.
Alright, now
Okay.
we gotta find the domain of fog.
Alright, now we have to find f composed of g. So I want f composed of g of x. I always rewrite it like this just because it helps my brain to think about what we're doing. So we're plugging g into f. Okay, plugging g into f. So instead of it being x squared minus 9, I put the inside stuff on the inside. So 9 minus x squared. Okay.
Just get rid of the square root, or do you have
Does the square get rid of the square root?
Yeah. but
Yes, it does.
In essence, it was like
Yep,
outside the
Yep, yep. So, let me just. So this square root and this square cancel each other out. So I've got 9 minus x squared minus 9, which is?
Negative squared minus 18.
This is a positive 9 and a negative 9.
I knew that. So
Gone.
it's
So it's just negative x squared. Okay. Now, what numbers am I allowed to plug in for that guy?
That x squared.
What? How did I get that x squared?
Yeah.
So this square root and this square cancel each other out.
Yeah.
Okay, so I have 9 minus x squared minus 9. 9 minus x squared minus 9. Okay, so 9 cancel out. So 9 minus 9 is 0. Goes
Yeah,
away.
that x squared.
Negative x squared.
Oh.
That's what's left over.
Oh, I was
Okay.
like, I haven't figured it.
So negative x squared, f composed of g, this guy is literally negative x squared. And I have to find the domain of him. So what am I allowed to plug in for x squared and what am I not allowed to plug in for x squared? I can plug anything I want to in for x squared except,
0.
even though I can plug in anything I want to in for x squared, I have to look at its pieces. So I was allowed to plug anything I wanted to in for this, but I can only plug in numbers there. So you have to take that into consideration as well. So I am only allowed to plug in numbers between negative 3 and 3. Even though my final answer, I can plug in anything I want to, I look at the two pieces, and the second piece told me, nope, you can't plug in any number, you can only plug in negative 3 to 3. So that is my overall domain. Do you remember that?
I just looked at that at the beginning and like, why did we do all that work?
I don't know.
I need a Red Bull.
Okay, negative 3 to 3, good? So this is the domain of the overall.
It's a Adderall.
Overall domain.
Cousin has that.
All right, last thing. Finding components of composite events. When we get to doing derivatives, listen.
Actually,
In chapter 6, we will start doing derivatives and antiderivatives. Okay, this is like what calculus is all about, derivatives and antiderivatives. We get to doing something called substitution, but it's not like substitution elimination substitution, it's like antiderivative substitution.
Oh, so we're doing this stuff?
And what you're doing is you're looking for composite functions, like one function stuck inside of another function. So if this is h of x, I want to break this down into two functions.
1 over x squared and x minus 2.
Yeah, look at you go. So that's one combination. So I could say f of x is equal to 1 over x squared, and g of x is equal to x minus 2. And what I've done is I've taken this guy and I've shoved it into there. So if I write them like that, is this f composed of g of x, or is it g composed of f of x?
The first one,
Because g is inside of f. So if we write those down as f is that and g is that, then h, this guy, is made up of f composed of g of x. Now, There's another combination that you could do.
I'm so confused.
You're so confused.
Yeah.
Okay, so what we're doing is we're taking this guy, Liddell, the original, and we're saying what two functions are inside of that.
It could be.
Okay. So we could say 1 over x squared,
1 over
and then
x.
taking x minus 2.
minus
This way,
2
say it, this way.
squared.
You're right. X minus 2 is getting shoved into there, and that would make this overall.
Oh,
Guy at the
okay,
end,
okay,
right?
okay.
And if we determine in that way, then it would be f composed of g of x. Okay, so now there's another way that we could do this. Okay, let's say f of x is what?
1 over x.
1 over x instead, not 1 over x squared, 1 over x. G of x would be
X minus 2 squared.
x minus 2 squared. So now we're taking this guy and we're plugging him in
That's
there.
the
Will
easy
that
way to
still
do
get
it.
me my answer?
Yes.
If I plug x minus 2 squared in for that x, will it still
Yeah.
get me the original? Yes, it will.
Mm-hmm.
Okay, is that f composed of g of x?
Yeah.
Or is it g composed of f of x? What?
No, it's the top
It's the top one. It's f composed of g of x. Okay? So, there are many different answers that you can get, right? This one had kind of 2 different answers that you could use. A lot of functions will have many different answers that you could use.
I need to check
If I
some
would
of
have
my
switched them
answers.
around, let's say this top one, I called this one f of x and this one g of x. Then
That's the thing.
it would be this one right here, right?
So you
G
can have
composed of f of
multiple
x.
answers, like
So you could have a ton of different answers depending upon what you call each one, etc. Right? Good.
Yeah, it's 'cause
Okay.
it's under here.
So these are defining composite functions. Okay,
Ugh.
and we do that a lot when we do antiderivatives and derivatives in chapter 6. We'll do a lot of this because you're kind of looking for what functions go inside of one another, and it's kind of cool. Okay, questions about that? That was really kind of super fast. Was that really super fast, or was it
Pretty quick.
okay? It was pretty quick.
But we understand it. so
Okay,
it's
there you
fine.
go.
But we need to do
Homework. For the people who are gone, homework is page 112. Is that right?
Yeah.
Page 112. 8 through 28 by 4s.
Hi, Keaton.
8 through 28 by
That's
4s.
Literally, I was sitting in bubbles and 4 people went in the office. I don't feel good.
34, 38,
It's because people psych themselves out.
Yeah.
50,
It's all mind over matter.
I feel like
and
that's
68.
If you don't have the round, if you say you don't have the roundies, then you don't get roundies.
There you go. There's your homework. Everybody say bye, Keaton and Caden.
Bye.
Bye.
Hey, Dad, I love
Bye.
you.